Hi everyone, this is Afroz Patan. I am an assistant professor in Department of Pharmaceutical Chemistry and Analysis, School of Pharmaceutical Sciences, Vistas. My topic is a name reaction called as Brich reduction, which is covered under first year Pharm.D POC subject. Coming to the introduction of Brich reduction, a reduction of aromatic rings, which is done in presence of sodium or potassium or lithium dissolved in liquid ammonia, and also in presence of an alcohol which act as a proton donor. The examples of alcohols can be used is ethanol, isopropyl alcohol, or tertiary butyl alcohol. This process is called as Brich reduction. Here, it will occur addition reaction at first and fourth position of benzene. Therefore, it gives a product called as cyclohexadiene, which is a non-conjugated double bond product. Generally, the alcohol which is used in the reaction is used to supply the protons, whereas sodium is used to transfer the electrons. Pyridine can also be reduced under this reaction, where pyridine will get reduced to 1,4 dihydropyridine. So you can see a example here. So benzene when you are taking and you are treating with sodium in liquid ammonia and also in which is dissolved in ethanol. So what is going to happen means among the three double bonds, one double bond got reduced and only two double bonds are retaining to give a product called as 1,4 cyclohexadiene and two hydrogens which got substituted at first and fourth position. That's the reason it is called as 1,4 cyclohexadiene. We will understand this with a better example. So here aromatic ring which you have taken, if it is reacted with sodium in liquid ammonia and ethanol, aromatic ring can be substituted with electron donating groups or even electron withdrawing groups. So examples which include electron withdrawing groups is OCH3, OH and NH2, and electron withdrawing groups presence like NO2, COOH or X. During this presence also, these compounds will undergo Brich reduction successfully. Mostly the solvent which you will use here is liquid ammonia, which dissolves sodium metal. Phenols and isolated double bonds are unable to get reduced by Brich reduction. Actually, conjugated if it is present, it is more feasible. Then, Brich reduction can also be used to reduce terminal double bonds in aliphatic chains. So here you can see an example where a substituted alkene which has a double bond at the last position called as terminal double bond, which gets reduced in presence of sodium in liquid ammonia to produce a substituted alkenes. Coming to the mechanism, here you can see the benzene which will react with the sodium metal and which has the ability to give one electron. Just assume the benzene has given the numbering and the first corner is first number, and if the numbering is given in the clockwise direction, so it will be like 1, 2, 3, 4. So the corners will be like first 2, 3, 4, 5, 6 like that. So if you react the sodium metal with benzene, here the sodium metal will give the electron at the fourth position of benzene, so forming as an radical. Whenever a radical has been formed, the double bond between third and fourth position and its first and second position is going to reshuffle, and the third and fourth position double bond has been shifted between second and third position, and first and second position double bond has shifted onto the corner carbon, that is first carbon. So this is what has been occurred in step 1, producing a radical at fourth position and a anion at first position, resulting into a formation of radical ion. Next, this when it undergoes step 2, this radical ion has the ability to accept a proton from the alcohol. So proton will transfer from alcohol as H plus ion, which will go and attack at the first carbon, it is corner carbon. So that already it has a, a electron pair. So it will form a bond. A CH bond is formed at first position, leaving behind our radical at the fourth position, resulting in the formation of radical ion. So in step 3, whatever the radical has been formed at fourth position, now it has the ability to accept one more electron from the sodium ion. So this sodium will give a electron to the fourth position of carbon. producing two electrons at fourth position. So it will produce a complete anion, that is carbanion. So here the radical has been changed into anion. In step 4, whatever the anion is there, it has two electrons. So definitely it has the ability to accept a H plus ion from ethanol. So which will go as H plus ion. So this H plus ion and these two electrons which are present at fourth position is able to form a bond, that is CH bond. So overall two hydrogens has been attacked at first position and also fourth position by reshuffling of electrons and double bonds, finally giving a compound called as cyclohexadiene. So these compounds generally it may also undergo Brich reduction. So the example one is reduction of benzoic acid. So benzoic acid, when it undergoes Brich reduction in presence of same sodium in liquid ammonia and ethanol, it will produce cyclohexa 2,5 diene carboxylic acid. So the double bonds has been reshuffled, and the hydrogens which got attacked, it will attack at second and fifth position. Next, one more compound is reduction of anisole. So if you take an anisole and treat it with tertiary butyl alcohol and sodium in liquid ammonia or lithium in liquid ammonia, this will produce generally 1-methoxy cyclohexa 1,4 diene. Means here also the hydrogens are attacked at first and fourth position, producing producing 1-methoxy cyclohexa diene. Next is reduction of toluene. So toluene, when it is treated with the sodium in liquid ammonia, it also produces 1-methyl cyclohexa 1,4 diene. These are the references from where I got the information. Thank you.